عسلامة مرحبا بكم الناس الكل. اليوم البريزونطاسيون نتاعنا باش تكون كلاود ات سكيل فروم اوبريشنز تو اوركستريشن. انا عزة كوكا انجينيور كلاود ات نيكست ستيب.
وانا عرفت بن كيلاني كلاود انجينير في نيكست ستيب.
So, good morning everyone. Today I would like to take you on a journey from traditional IT operations to intelligent cloud orchestration. We are not here to talk about one product. We are here to talk about a transformation where infrastructures become automated, systems become intelligent, and operations become orchestrated. Our journey have three main chapters. The first one is to understand how the cloud evolved. Then we will explore the automation, which is teaching the machines to do the repetitive work. And orchestration, which is making all these tasks working all together as one system. And finally, we will see how the security must be embedded into everything. So let's rewind a little and go back to where everything started. At its core, the cloud is very simple. It gives us compute power, storage, and networking. But all delivered as a services. So instead of buying physical servers, we consume resources when we need them. So the cloud transformed the infrastructure from something heavy and physical to something flexible and scalable. But the cloud didn't become intelligent overnight. It evolved. So we started with the lift and shift, where companies simply moved their servers to the cloud, and then came the cloud-native applications, then hybrid and multi-cloud environments, and today we are entering the era of the intelligent cloud. So the infrastructure is no longer static. It adapts, it predicts, and it optimizes. The cloud is no longer just about technology. It's also about strategy. Organizations must choose based on performance, optimizations, and business needs. We have the private cloud, which gives you a full control. Also, we have the public cloud, which gives you elasticity, and the hybrid cloud gives you flexibility. So. Organizations must choose based on the model, but no matter what the model they choose, there are many levels and maturity journey that these organizations will follow. At level 1, we have the traditional physical servers, manual provisioning, weeks to deploy, and it is slow and rigid. Then came the virtualization, which changed the game. Now we optimize the efficiency, but it's not still intelligent enough. So we moved to automation. Here we introduced infrastructure as a service, CI/CD pipelines, and basic auto-scaling. But still, automation alone is not enough. So there is the orchestration, which will make all the automated tasks with the automation will work all together as one system. And the highest level is the intelligent cloud. And this is where the cloud become proactive. Systems are no longer waiting for failure. It predicts it and fixes it automatically. So to reach this level, we have many strong pillars. So the first pillar is the automation. Automation started with simple scripts. Do this one thing. Then do this one thing. And then the configuration of management. Make all servers identical. And then with the infrastructure as a code, we build everything from code. And now the autonomous cloud, who will detect everything and fix it automatically. But automation alone is not the most powerful example of the automation is the auto-scaling. When we needed more resources to work, we go to two types of scaling, which is the virtual scaling and horizontal scaling. The virtual scaling allows us to add more resources, but when we stop the server and upgraded it. And this means downtime. But in horizontal scaling, there is zero time because we can add instances, unlimited instances, as much as we need. The auto-scaling will allow us zero downtime, a very high availability, and the cost reduction. وبيسكل كلنا نعرفوا اللي الابليكيشنز are critical والداون تايم يعني برشا فلوس واللي هو معناها ما نجموش معناها الحاجة هذيا on ne prend pas en considération. So automation is very powerful, but automation alone is doing all tasks, doing one task by one. So we get to the coordination. Orchestration is making all tasks work together as one system. At the first, applications were very fragile, but then containers standardized the deployment, and Kubernetes take it further. It works on my machine was very common, and the containers fixed these problems, and Kubernetes also with the orchestration make this problem resolved. Kubernetes is the operating system of the cloud. It decides where to schedule the applications, restart crashing instances, distribute traffic between the nodes, and also managing the secrets and configs of our applications. But nowadays, systems are more powerful than that. They can heal themselves, and also they can monitor themselves for every few seconds. So, for example, if a server fails, it replaces it. If a disk space is critical, it extends it or clean it. And also, if memory leaks, it reroutes traffic and restart gracefully. So systems become anti-fragile, stronger with every failure corrections. But organizations want one cloud is not enough for our organizations, so they can go for the multi-cloud strategy. But why multi-cloud? Because it gives us compliance, resilience. We can get the best of service of each provider, and also to avoid the vendor lock-in of the cloud providers. But orchestration تنجم تزيدنا الكومبلكسيتي هذيا واللي will be managed by a unified orchestration layer اللي هي باش تخليك تعمل workload placement, security governance and cost optimization for the applications اللي هما باش يكونوا يخدموا على multiple cloud providers واللي احنا نجموا for example ناخذوا الماشين learning from AWS, ناخذوا الانتربرايز from Azure ونقسموا معناها الكلاود الابليكيشنز نتاعنا على الكلاود providers وهكيكا الorchestration هي will decrease the complexity of the multi-cloud providers. So orchestration is not only about infrastructures, it's also about workflows. So imagine a developer requests an environment to work with. Instead of manual approvals and emails, the system can just create the project, provision the infrastructure, apply firewall security, and configure CI/CD pipelines for their applications. And also, he will enable the monitoring and send notification to that developer, which will ربحنا برشا وقت اللي احنا كنا نجمو نخسروه في الايميلز والمانيوال ابروفلز اللي هما باش يضيعونا برشا وقت للابليكيشنز نتاعنا باش تولي معناها التايم تو ماركت نتاعها باش يعلى اكثر. So the orchestration effect. We moved from raw infrastructures to coordinated platforms, from tools to unified workflows, and finally to a measurable business value.
But without security, everything that we've talked about falls apart. So when we say cloud security, people usually think about encryption, passwords, firewalls, but it's much more than that. Uh, so it's rather the combination of strategies, the technologies, and the processes that protect the cloud environment. So to really build a secure cloud environment, we rely on six fundamental pillars. Think about it like a building. If one pillar is weak, the whole structure becomes unstable. So the first pillar is access management, which is it's all about the control of who can access what. The second pillar, which is zero trust, which stands for trust nothing, verify everything, and enforce least privilege. And the third pillar is all about protecting data at all time. The fourth pillar, which is about tracking modifications and ensuring that they do not introduce new security vulnerabilities. The fifth pillar, which is about automating workflows, security workflows to ensure that less human errors and to faster reactivity. And the last pillar is about seeing everything in the environment in real time. So as you can see, the six pillars work together to help create and build secure and resilient cloud environments. So as you can see, cloud security is not a single mechanism, but rather a unified system of layers that reinforce each other. So controlling access. So controlling access is the foundation of cloud security, and it consists of four key components. User management, which is all about creating, managing, and deleting digital identities. Authentication, which is all about verifying that users are who they claim to be. Authorization, which is all about granting or denying users permissions to access specific resources in the cloud. And access governance, which is all about enforcing and auditing access policies and compliance. So identity and access management ensures that the right users have the right access at the right time. But what if we don't trust anything by default? This is where zero trust comes into picture. According to unlike traditional security models where they assume that everything in the network are to be trusted, zero trust assumes the opposite. Threats can exist anywhere. And as you can see in this architecture, zero trust sits at the center of everything: users, devices, applications, cloud resources. So to simplify it even more, we can break it down into five key domains. Zero trust devices, so access depends not only on the user, but also on the security posture of the device being used. The second domain, which is zero trust data, so data must be encrypted, classified, and protected all times, regardless of where it resides. And the third domain is zero trust networking, so the network must be segmented to prevent lateral movement and unauthorized access. The fourth domain is zero trust workload, so the applications and the running services must securely authenticate and communicate with each other. And last but not least, zero trust people. So as we've seen in the identity and access management section, every user must be strongly authenticated and granted only the minimum necessary access. Now, the question remains is what are we really trying to protect? And the answer is simple: data. So at the end of the day, data is the most valuable asset in the cloud. We can rebuild application, we can redeploy infrastructure, but if data is lost or compromised, it will cause irreversible damage. And in the cloud, data faces a lot of threats, from malwares to ransomwares, to unauthorized access, to data breaches and data corruption, to insider threats, accidental data deletion, poor security patching, shared responsibility between the cloud provider and the cloud consumer, and compliance and the legal requirements, and so many more. And in order to protect it, organization must implement multiple layers of protection. First, we need to control who can access the data through a robust identity and access management framework. Second, data must be encrypted at rest and in transit using very strong encryption algorithms, and we need to manage the encryption keys very carefully. Third, since no system is immune to failures, we need to have data backup and disaster recovery plans in place. They are critical, especially against ransomwares or accidental data deletion. And fourth, we need to set up monitoring and logging for visibility and data reactivity. And fifth, we need to ensure proper patch management, and this will reduce vulnerabilities before they are exploited. Also, next, we need to segment our network and utilize a very strong storage architecture in order to limit the exposure and the attack surface. And last but not least, regular security assessment and audits to ensure controls remain effective over time. Okay, so we talked about protecting data, but there is still one important challenge in cloud environments, which is speed. So cloud environments change constantly, provisioning new users, new deployments, new configuration every day. And honestly, manual security workflows are not enough. And this is where automating security workflows and change management becomes critical. So misconfiguration is one of the biggest risks. And luckily, we can automate it using various technologies. Second, automating vulnerability scanning. So instead of waiting for an incident, the system continuously checks itself. Third, like we talked, identity and access management can be automated, and this will reduce delays and prevents forgotten accounts. And last but not least, automating patch management. The faster the vulnerabilities are patched, the smaller the attack window, obviously. Okay, now how can we see if all what we saw works together? This is where observability comes in place. You can't secure what you can't see. So observability gives us visibility across all our cloud environments, from networks to infrastructure, to users, Internet of Things, applications, and obviously databases. Okay, enough of security. Now I want to give you a glance at the future of cloud computing. So we all know AI, the rise of AI, and it being adopted in various sectors. And obviously, it have a lot of applications in cloud management. So the first application is AI-powered traffic prediction. So by analyzing historical patterns, AI can predict traffic spikes before they can happen, ensure the system are ready in advance. Also, resources can scale automatically, not just reactively, but predictively using various machine learning based algorithms. AI can also detect abnormal system behavior early and prevent outages before they impact users. Fourth, we have something in cloud computing, which is load balancing. So instead of static rules, AI can dynamically distribute traffic based on real-time behavior and demand. And in regard of security, AI can enhance the security posture of our cloud environments by detecting anomalies faster than traditional rule-based approaches. And last but not least, AI can continuously analyze the system performance and automatically optimize configurations for efficiency and costs. Thank you for your attention.
إذا كان عندكم أسئلة بيان سور تنجموا تسألونا معناها كان فما شكون عنده أي سؤال. Any question? جست شو نقول حاجة على next step بيان سور كلكم تعرفوا اللي احنا next step we are the we are cloud provider. عندنا البارتي عندنا نخدموا infrastructure as a service, platform as a service, عندنا security operation center وكيف عندنا networking operation center. وبالطبيعة مرحبا بكم الناس الكل إذا كنت تحبوا تعرفوا أي حاجة أكثر على next step مرحبا بكم بحضنا في next step.